Hello everyone, I'm Himanshu Vasnani from Department of Mechanical Engineering. I'm here to discuss with you on the subject non-destructive evaluation and testing. The subject code is ME419, unit number 3, lecture number 21 in the series. And today's topic are welding inspection, tube inspection, thickness measurement, and ultrasonic testing of composites. Okay, so let's start. Now, today's learning objectives are to provide the students with a basic understanding of welding inspection, tube inspection, thickness measurement, and ultrasonic testing, and to know about ultrasonic testing of composites. The learning outcome after today's lecture will be the students will have an understanding of welding inspection, tube inspection, thickness measurement, and ultrasonic testing, and students have understood the ultrasonic testing of composites. So let's start with today's lecture. Now, we have studied about various kinds of calibration methods and about radiation parameters about in the last previous lecture. Okay, in this studied about optical parameters and various parameters that were used to you can say uh, to measure to help that are helpful in ultrasonic testing. So let's go. Now we are studying about welding inspection. So welding is an essential manufacturing process performed in almost every major industry. Therefore, weld quality and integrity are critical to safety in an extremely wide range of products and structures. Okay. So inspecting welds can also reduce cost by detecting discontinuities in the early stages of manufacturing, reducing the cost of rework and extending the life of components by detecting and correcting flaws. Now here you can understand and you can just say the welding. See, welding is a manufacturing process that is used in you can say in many applications. Okay, because two of the most important production processes like casting and welding, because casting is used to manufacture, you can say, cast a product or workpiece, okay, through die casting process or anything. So there also some kind of defects are found, and welding on other hand is another metal joining process in which you can say some kind of defects may come. So, this welding is a very important application in the manufacturing industry or any other, you can say, as you can say in the general industries. So, we have to find you can say, defects in the welding zones or in the welds or in the weldments in order to avoid some, you can say, mishappening or any kind of unwanted thing in the industry. Okay, so because you understand if the weld quality is good, okay, then it will give you a better structure. Okay, and if the weld quality is bad, then bad means not good enough, though the structure will be disturbed. Okay, so we have to inspect the welds also, because if we inspect means here we have to check the welds also. If the welds are good, then automatically the you can say the cost of you can say either mishappening and the cost of rework that would that would that may happen, it will be reduced. Okay, that will be reduced. So here they are saying that inspecting welds or this weldments, this can also reduce the cost by detecting the discontinuities in the early stages of manufacturing only, and this will reduce the cost of rework, and this will you can say extending the life of components by detecting and correcting flaws. Okay, so some kind of flaws that are detected in this weldment, these are shown in the diagram of like there is a porosity kind of a you can say defect shown. Then slag inclusions means some exterior kind of a material that has entered the welding zone and is get trapped inside the weldment only. Then the toe crack, you can easily see some kind of a toe crack is there, or the root crack is there. Okay, these cracks, they you can say they disturb the strength of the weldment. Okay, then lack of fusion is there. Okay, it's like the base metal and the filler metal, they might not fuse together properly due to any reason. So this will also weaken the strength of the weld. Okay, so NDT methods we are studying about ultrasonic testing. So these can identify the cracking or porosity or incomplete penetration. Incomplete penetration means that the pillar material is not able to reach a particular part of the welding zone. Okay, it cannot penetrate. It didn't penetrate it completely as it should be. Okay, so misalignment, inclusions, and lack of fusion and similar conditions which can compromise the weld strength. That was I was talking about. The weld strength will be compromised if such kinds of defects are present. So we should try to inspect and find out if such kind of defects or discontinuities are found in the welding zone and should be improved as soon as possible. One of the largest applications of ultrasonic testing in NDT is weld inspection, right? I just told you. Now, one of the largest applications of ultrasonic testing in NDT is weld inspection. So, techniques vary due to weld material or weld thickness or weld process and even code requirements. Okay, so if we go with the weld inspection, then weld inspection by standard ultrasonic methods like manual contact testing is usually restricted of plates with thickness of around 10 mm to 12 mm or more. I repeat, you understand this thing. Then weld ultrasonic methods like manual contact testing is usually restricted to joining of plates with thickness of 10 mm to 12 mm or more. The greater the refraction angles used for thinner welds can veritably flood the piece with sound. So surface waves and mood conversion of lobes, divergence and near zone effects can all provide misleading signals. Okay, because see what happens during the inspection by like ultrasonic testing methods. Okay, like if you are going for a manual contact testing, manually you are testing the, you can say, welding. So it's usually restricted to joining of plates with thickness of around 10 mm to 12 mm or more, because this you can easily do it. But if apart from that, if you can say mm, the greater the refracted angles used for thinner welds, okay, and it can veritably flood the piece with sound, okay, and this will affect the nearby zones and provide misleading signals. So this is a general diagram that I just told you before also, the various defects or discontinuities in the welding zone that can be seen that I just told you. Then an ultrasonic technique for weld inspection should investigate the total weld volume plus a region either side of the weld considered to be the heat affected zone. Okay. Now, when geometry permits, the weld should be inspected from at least two sides. Okay. So, a normal beam scan is usually performed over the metal on which the shear wave probe will transverse. I repeat, when geometry permits, the weld should be inspected from at least two sides. Okay, a normal beam scan is usually performed over the metal on which the shear wave probe will transfer. So this provides thickness information and indicates areas where plate laminations might exist and interfere with the shear wave beam. So scan patterns for manual weld inspection are usually zigzag with some overlap to ensure 100% coverage. Like some technicians, they add a pivoting motion to the forward and backward zigzag pattern. Why they do this? To enhance detection of angle flaws. Okay. So other prefer to scan in three directions only. So the first, they say that the first perpendicular to the weld center line, then plus 45 degree to the weld center line, and then minus 45 degree to the weld center line. So the scanning speed should be slow enough to maintain coupling and ensure the operator that operator can monitor all events on the CRT. Okay, so in this way they go with the scanning process. And this is how the ultrasonic inspection of weld part is done. I have also discussed about this about the diagram in the previous lectures also, in which you can see the uh, capital T thickness of the weld, and then the you can or the thickness of the workpiece, sorry, and then there is a skip distance, and then path sound path leg 1, sound path leg 2, and then theta r. These all we have discussed in our other classes also. To determine the proper scanning area for both sides of the weld, the inspector must calculate the skip distance of the sound beam, okay, using the refracted angle and material thickness. As you can say, okay, uh, uh, using the refracted angle and material thickness, as you can, skip distance is equals to twice of t into tan theta of r. Okay, this is the formula for the skip distance, that you can see the horizontal distance that is shown from the transducer to the starting of the weld, okay, welding zone. So now we go with the tube inspection part. Okay, now the in ultrasonic testing of different tubes, okay, is a commonly used method of inspection. Okay, various techniques and inspection systems are employed for tube examination. However, sometimes there are serious problems with complex delivery systems and ultrasonic inspection time, because of necessity to provide 100% volumetric coverage of the tube by rotating the probe module. The ability to perform the ultrasonic inspection without mechanical rotation of probe module will lead to significant simplification of the delivery system and decrease of the inspection time due to increase of the axial speed of the inspection system. So moreover, the necessity of rotation decreases reliability, okay, and sensitivity of the inspection system because of mechanical vibrations, radial shifts, and possible jumps, electromagnetic noise from rotating motor, and so on. So, therefore, in general, the possibility to get rid of rotation is extremely attractive, and it will lead to a significant financial benefits. Okay, so this is how they go for tube inspection. Now this is just a diagram showing how they are going for inspection of pipes. Okay, and the arrow is, the direction is shown by the arrow, and you can see how they are inspecting it. Now thickness measurement. Okay, now in the field of industrial ultrasonic testing, ultrasonic thickness. Okay, mhm, ultrasonic thickness measurement (UTM), one of the most important term in ultrasonic testing is ultrasonic thickness measurement (UTM), is a method of performing non-destructive measurement, that is gauging of the local thickness of a solid element. Okay, and it is typically made of metal. It's using ultrasound uh, testing for industrial purposes, basing on the time taken by the ultrasound wave to return to the surface. So this type of measurement is typically performed with an ultrasonic technique gauge. Okay. Now ultrasonic waves have been observed to travel through metals at a constant speed characteristics to a given alloy with minor variation due to the other factors like temperature. So thus given this information called celerity, okay, one can calculate the length of the path traversed by the wave using the simple formula. Okay. Now here they are telling about the ultrasonic thickness measurement technique. Okay, where you perform like non-destructive measurement of the thickness of a solid element. Okay, and based on the time taken by the ultrasonic or ultrasound wave to return to the surface. Okay, so in this way they go for a thickness measurement. So this time given, so thus given this information called celerity, one can calculate the length of path traversed by the wave in a simple formula, that is Tm of is equals to Ct by 2, and is Tm is the thickness of the sample, and Ct, that is C, is the celerity of sound in the given sample, and T is the transverse time. So in this way, you find out the, you can say, information regarding the sample. The formula features division by 2 because usually the instrumentation emits and records the ultrasound wave on the same side of the sample using the fact that it is reflected on the boundary of the element. Okay, so this the time corresponds to the traversing the sample twice. Okay, the wave is usually emitted by a piezoelectric cell or EMET sensor that is built into the measurement sensor. I repeat, what happens that the time corresponds to the traversing the sample twice because you can say the when the waves go and it is reflected to the boundary or reflected on the boundary of the element. Okay, the wave is usually emitted by a piezoelectric cell, obviously, or EMET sensor that is built into the measurement sensor head, and the same sensor is used to record the reflected wave. Okay, the sound wave has a spherical pattern of propagation and will undergo different phenomena like multipath reflection or diffraction. So the measurement does not need to be affected by these since the first recorded return will normally be the head of the emitted wave traveling at the shortest distance, which is equivalent to the thickness of the sample. Okay, so in this way they are processing the measurements of this workpiece. Now the elastic constant determination. Okay, this is a very important thing. Now here, what they're saying that the elastic measurement behavior of the elastic mechanical behavior of, you can say, elastic constant, elastic material is modeled by a pair of independent constants like Young's modulus and Poisson's coefficient. The precise measurement for both constant is necessarily in some applications such as quality control of mechanical elements and standard materials used for the calibration of some equipment. Okay. The ultrasonic techniques have been used because the wave velocity depends on the elastic properties of the propagation medium. Okay. The ultrasonic test here shows better repeatability and accuracy than the tensile and the indentation test. Furthermore, an amorphous material and some polycrystalline materials were tested so for determining this constant. Ah, so the elastic properties of solids are the key properties for the design of mechanically loaded components, especially the elastic modulus and the Poisson's ratio, which are the properties that thoroughly describe the elastic behavior of isotropic material. Here, the ultrasound is a technique that meets all requirements mentioned above, and which take advantage of the principle that the propagation velocity of the waves through a solid medium depends on the solid elastic properties. So this technique is so useful that it has become popularly because other fields in the composite material medicine buy it. Ultrasound uses very high frequency sound, higher than 20 kilohertz, the limit of human hearing. Okay, and to determine material characteristics of interest such as the presence of cracks or voids, porosity, part thickness, and weld penetration. Then this, so you will measure the how does this, you can say, go for it. So for longitudinal waves, the motion of the particles is parallel to the direction of propagation. For shear waves, the motion of particles is perpendicular to the direction of wave propagation. So the wavelength is like v upon f, and f is the frequency, wave frequency. Okay. So these diagrams also depicts how the, you can say, waves in bulk solid like longitudinal waves and shear waves. So if you go with the longitudinal wave, you can see that the direction of particle motion is shown by the arrows, and then direction of wave propagation is also shown there, and the wavelength is there. And if you talk about the shear waves, then also you can see the wavelength is decreased as compared to the longitudinal wave. And the particle motion, the actual particle motion is also different. Okay, in this, as we, and the direction of wave propagation is still on the right hand side, that is shown in the shear wave also. So there is a, you can say, difference of wavelength and the direction of particle motion if you compare the longitudinal and shear waves. Okay, It will be shown that the speed of sound of longitudinal and shear waves given by CL is equals to under root of V uh, into 1 minus V upon rho into 1 plus V into 1 minus 2V. Okay, this is the equation, and then CS is equals to like E upon twice of rho into 1 plus V is equals to under root of G upon rho. So this formula we have discussed earlier also. Where E is the Young's modulus or the modulus of elasticity, U is the Poisson's ratio, rho is the density, and G is the shear modulus. Solving these equations of E and you can say V gives like V is equals to 1 minus 2 into Cs upon Cl square upon 2 minus 2 Cs upon Cl whole square. That is E is equals to twice of rho Cs square upon 1 plus V. These are simple formulas that we have discussed earlier also. Okay. Now ultrasonic testing of composites. So ultrasound pulses are affected by interfaces between part properties. So in the case of delamination and response, this can cause a discrete reflection from a particular depth in the material. So such a reflection can result in loss of transmission to the material. So porosity here does not produce a discrete reflection but scatters the ultrasound in a range of directions, also resulting in a transmission loss. Okay, does not produce a discrete reflection, but it scatters the ultrasound in the range of direction, resulting in a transmission loss. So these transmission losses can be detected by mapping the transmitted signal over a whole structure, and this is known as through transmission C-scan. We have discussed this about earlier also. So variations in the transmitted signal can be caused by a delamination, or either disbonds or porosity. Okay, so mapping the time delay to reception of the reflected signals provide information about the depth of the damage, and this is known as a depth or time of flight scan. So the information about the defect depth can be used to view the ultrasound data as a pseudo 3D image. Now the composite materials that we are discussing are widely used in a number of industrial sectors, from aviation to space to boat buildings to automotives and sports goods. So in recent years, composite structures have seen a increase in their use in the new generation of airplanes. So composite structures can be divided into an approximately two large categories: laminates and bonded sandwich structures. Okay, the use of these composites in the aviation industry started by employing honeycomb panels as flight control surfaces, fairings, and engine nacelles. So, composite sandwiches with foam core have been used in boat buildings, on helicopter rotor blades, okay, and in radomes. So in recent years, you can say thickness laminates are increasingly employed as primary load-bearing structures on aircrafts. Now you can see in this diagram also it is showing you the composite damage, that is like delamination caused by the impact on solid laminates. Okay, this is how you can see the delamination portion shown here. Okay, and this is the diagram just showing the core fraction. Okay, core fracture in the honeycomb sandwich. Okay, so this is how they display this damage caused in the composites. Okay, now of the many NDI techniques beyond visual inspection, you have understood this kind of okay, this is kind of a damage shown to you. One of the many NDI techniques beyond visual inspection and manual tap test, ultrasonic testing probably comes first to mind. Okay, what happens that however contact nodes can type point-to-point measurements have limited capabilities, especially in the inspection of honeycomb sandwiches. A number of ultrasonic systems capable of doing C-scan imaging in the field have been developed, although the enhanced capabilities associated came with the associated greater complexity. Higher unit training is required for that, and reduced portability and higher costs are also involved. So there are two non-contact modes of ultrasonic inspection. One is laser generated and detected ultrasound, and the other is air coupled ultrasound. Okay, laser generated and detected ultrasound, and the other is air coupled ultrasound. The former has matured to a degree that industrial implementation are in place, and the latter is also finding increased applications. So just remember the two non-contact modes of ultrasonic inspection are like one is laser generated and detected ultrasound, and the other is ear coupled ultrasound. So they have their applications also. So the two recently developed technologies like the acoustography and the ultrasound camera, acoustocam, they hold the potential for providing large area ultrasonic images in real time or near real time without the need of performing a C scan. Acoustography and acoustocam, okay, one of the recent technologies. And the acoustography employs a stress-sensitive liquid crystal material that converts the ultrasonic field intensity containing the flawed indication into an optical gray scale image. And the acoustocam is based on a piezoelectric readout multiplexer that operates like a CCD array and provides a visual image of the ultrasonic field at the video rate. Now both the acoustography and the acoustocam require water coupling of the ultrasound to the composite part. Now the two optically based non-contact, non-destructive inspection methods capable of large area scan at a rapid rate are the thermal wave imaging technique and the laser shearography. Now going beyond conventional infrared thermography or you can say thermal wave imaging applies a heat pulse. This thermal wave imaging applies a heat pulse to a composite surface. Okay, it's applying a heat pulse to a composite surface with a flash lamp and then captures the surface temperature profile as a function of time. So analytical methods and softwares have been given the techniques, deep penetration and quantitative flaw characterization capabilities. And other high-speed area inspection technique, laser stereography, detects subsurface defects by measuring the minute difference in surface deformation over a good region and over a defective region when a composite part is slightly stressed. So in this way, stereography is helpful. A stereography instrument detects the difference as a shift in the phase separated the stereography instrument it detects the difference as a shift in the phase separated optical images of the reflected laser line. I repeat, you understand this statement. A stereography instrument detects the difference as a shift in the phase separated optical images of the reflected laser line. Okay, and the technique has superior sensitivity protecting subsurface flaws. So the importance of stereography is very good. Now this is diagram of the ultrasonic testing for producing scan images is shown to you. Like you have a specimen and you have a transducer available with you with a position sensor, and this is you can say attached with the standard NDI equipment that is using the flaw detector or thickness gauge or dedicated instrument or bond master or syndicator or MIA or ear couple ultrasonic testing, etc. Whatever you want to say. Then you have a position encoding system which is helpful with the help of position sensor, and that you can easily see on the your notebook PC or on a laptop or on whatever display you are having with you. So this is how you can see that the equipment, the NDI equipment is attached with the transducer and the position sensor that is used is attached with the position encoding system. So they are trying to capture the location and the you can say defect both how simultaneously and displayed on the screen. Now the advantages of ultrasonic testing. Now, this is has high penetrating power which allows detection of flaws deep in the part. It has high sensitivity, permitting the detection of extremely small flaws. It has only two only two non-parallel surfaces needs to be accessible and greater accuracy than other non-destructive methods in determining the depth of internal flaws and the thickness of parts of parallel surfaces. Some capabilities of estimating the size, orientation, shape, and nature of defects. They are non-hazardous or to operations or to nearby personnel and has no effect on the equipment and materials in the vicinity and capable of we can say portable or highly automated operations. So these are the advantages of ultrasonic testing. So it is good. It is good because the non-hazardous to operations on nearby personnel and has no effect on the equipment and materials in the vicinity is good. This is a good advantage. Okay, and it has good accuracy, greater accuracy for determining the depth of internal flaws and thickness of parts with parallel surfaces. So this is a very high, you can say, good advantage that is available with it. Not disadvantages also. And the manual operation requires careful attention by experienced technicians. Okay, the transducers alert to both normal structure of some materials, the tolerable anomalies of the specimen, both term noise, and to faults therein severe enough to compromise specimen integrity. So these signals must be okay. Okay, whatever signals you are getting, these signals must be distinguished by a skilled technician, possibly after follow-up with other non-destructive testing methods. So the you can say if some issues is there, they also give some signals, and these can be distinguished by a skilled technician only. Okay, so you should understand, and that is why they are saying that the manual operations they require skilled technicians and which are attentive enough to understand the signals. Okay, because the transducers they alert to both normal structure of some materials, tolerable anomalies to other specimens, both from noise and to faults. They are severe enough to compromise specimen integrity. So if you have a skilled technician, then it will be you can say able to understand all these things. An extensive technical knowledge is required for the development of inspection procedures. Obviously, the inspector should have the technical knowledge well enough. And parts that is rough, irregular in shape, very thin or thin, very small or thin, or not homogeneous are difficult to inspect. Okay? The surface must be prepared by cleaning and removing loose scale, paint, etc. All the paint that is properly bonded to a surface need not be removed. We have discussed this earlier also very in detail. Okay. Now, couplants are needed to provide effective transfer of couplants are needed to provide effective transfer of ultrasonic wave energy between the transducers and the parts being inspected. Okay. Okay. The couplants are needed to provide effective transfer of ultrasonic wave energy between the transducers and parts being inspected unless a non-contact technique is used. So non-contact technique include laser and electromagnetic acoustic transducers (EMAT). See, this is a very important, you can say, point that you should understand that the couplants that we are using, these are needed to provide effective transfer of ultrasonic wave energy between transducer and the part being inspected unless a non-contact technique is used. Okay. A non-contact technique includes like laser and electromagnetic acoustic and transducers. That is why they are saying that the couplant should be chosen wisely. Uh, Inspected items must be water resistant when using water-based couplants that do not contain rust inhibitor. That is it. The applications of EOT ultrasonic testing is like flaw detection and then erosion corrosion thickness gauging and assessment of bond integrity, estimation of grain size in metals or estimation of void content in composites and plastics. These are some applications that should be discussed. Okay, now we are discussing about some common, you can say, calibration blocks of different designs. Okay, that are used. So the type of standard calibration block that is used here is dependent on the NDT application and the form and shape of the object being evaluated. So for this, we have the commonly used standard calibration blocks like for the blocks like for International Institute of Welding (IIW) and from American Welding Society (AWS) and from the American Society of Testing and Materials like ASTM. So out of these three, the two of the most commonly used standard calibration blocks are like IIW Type US1 calibration block. So this is a general purpose calibration block you can see in the figure also that can be used for calibrating angle beam transducers as well as normal beam transducers. Okay, the material from which IEW blocks are prepared is specified as steel, open arc, or electric furnace, low carbon steel in the normalized condition with a grain size of max to at EHN number 8 fine grain. So these are some technical things. So official IEW blocks are dimensioned in metric system of units. Yeah. So this block has several features that facilitate checking and calibrating many of the parameters and functions of the transducers as well as instruments, which includes like angle, beam, exit point, or beam angle, or beam spread, time base, and linearity, resolution, dead zone, sensitivity, and range setting. Since it is a calibration block, so you can see the diagram also, which shows that how the determination of index point is done, then determination of beam angle is done with this block, and then how does the calibration of instrument time base is done. And these are just for you can say understanding that okay, this is a block from IEW that needs that is used. Okay. Now the second block is like the second technique is ASTM, like miniature angle beam calibration block V2 version 2. So in this say that the miniature angle beam block is used in somewhat similar manner as the IW block, but is smaller and lighter. The miniature angle beam block is primarily used in the field for checking characteristics of the angle beam transducer. Now here it is used for angle beam transducer. Now with the miniature block, beam angle and the exit point can be checked for an angle beam transducer. Both the 25 and 50 radius surfaces provide ways for checking the location of the exit point of the transducer. Okay, and for calibrating the time base for of the instrument in terms of metal distance. So there are small holes. The small holes they provide a reflector for checking the beam angle and for setting the instrument gain. This is in the diagram. You can see this. Okay, and understand that these are some calibration blocks that are used IEW and ASTM, two of the most common blocks. Now let's start with the MCQs for today. In ultrasonic testing, mapping the time delay, uh, mapping the time delay to reception of the reflected signals provide information about the depth of the damage, and this is known as what do we call this? What do we call this? We call it as either pulse echo testing, but pulse echo testing is different thing. It is like you are giving a pulse, and if it is reflected back from a surface, then it is pulse echo testing. This is different thing. Uh, Through transmission C scan, no, because transmission means you have a sender from one side and you have a receiver on the other side, and then the wave travels only one time. So this is not okay. Thickness measurement, by reading the statement, no kind of thickness measurement is shown, like in ultrasonic testing, mapping the time delay to reception of the reflected signals provide information about the depth of the damage, and this is either known as depth or time of light scan. Okay, this is like depth or time of light scan. Now in the field of industrial ultrasonic testing, this is the method of performing non-destructive measurement like gauging of the local thickness of a solid element typically made of metal if using ultrasound testing for industrial purposes basing on the time taken by the ultrasound wave to return to the surface. Okay, I repeat and understand the system. Okay, it's in the field of industrial UTST, ultrasonic testing. It is a method of performing non-destructive measurement. Now the term measurement is coming. Okay, and obviously gauging is there of the local thickness of a solid element. Okay, typically made of metal. It's using ultrasound testing for industrial purposes, basing on the time taken by the ultrasound wave to return to the surface. So what do we call this? We call this as ultrasonic thickness measurement. Okay, it's very you can say interpretable with the statement also. In the field of industrial ultrasonic testing, it is typically performed with an ultrasonic thickness gauge. So if gauge is there, means some measurement will be done. Okay, as we just discussed previously in the last question also. So thickness measurement or some measurement is there. So if measurement is there, then ultrasonic thickness measurement is the answer. Now in the pulse testing, pulse echo testing, sorry, in the pulse echo testing, the time of flight, okay, TUF scan has been developed in order to allow delaminating or tracking to be identified and localized with a better accuracy. Okay, the principle of TUF measurement is based on the object distance and time of flight relations. I just discussed with you in today's lecture that okay, this is the thing. So I think it's uh, the principle of TUF measurement is actually based on the object distance and the time of flight relation. So I think it's true. It's true. Okay. In ultrasonic testing, okay, a transducer sends out a pulse of energy and the same or a second transducer listens for reflected energy. Okay. A transducer sends out a pulse of energy and the same or a second transducer listens for reflected energy. What do we call this? In the starting of the MCQs, I told you about this. This is pulse echo testing. Okay. In this, what happens that you can say that the word echo is there, so means energy is sent and you can send the reflected energy is gained. So if you understand the statement very well, then pulse echo testing will automatically be the answer. Okay. Understand the statement and then try to interpret. Okay. Now these are typically used to introduce a refracted shear wave into the test material and allows the sound beam to come in from the side, thereby improving detectability of flaws in and around welded areas. I repeat once again, understand it. These are typically used to introduce a refracted shear wave into the test material and allows the sound beam to come in from the side, thereby improving the detectability of flaw in and around welded areas. We have discussed just in the starting during the welding inspection topic, okay, about these kind of instrument. I repeat and you understand, okay? These are typically used to produce a reflected shear wave into the test material and allows the sound beam to come in from the side. Now, come in from the side and thereby improving detectability of flaws in and around the welded areas. So it is angle beam instruments, angle beam transducers and wedges. Okay, angle beam transducers and wedges. Now, angle beam inspection is somehow different than a normal beam inspection. Like in normal beam inspection, the back wall echo is always present on the scope display, and when the transducer passes over the discontinuity, a new echo will appear between the initial pulse and the back wall echo. Okay, you can understand that the this is showing the difference between angle beam and normal beam inspection. So they say that angle beam inspection is somehow different from normal beam inspection, like in normal beam inspection. Okay, now you're comparing the angle beam with a normal beam. How it is different? They are saying that in normal beam inspection, the back wall echo is always present on the scope display, and when the transducer passes over a discontinuity, a new echo will appear between the initial pulse and back wall echo. So, what do you say about this statement? Is it true or false? Is this true? Now, pulse echo ultrasonic measurement can determine the location of a discontinuity in the part or structure by accurately measuring the time required for a short ultrasonic pulse generated by a transducer to travel through a thickness of material reflect from the back or the surface of a discontinuity and be returned to the transducer. So what do we call true or false? We just discussed we told just few minutes ago. It's true. Okay. So in ultrasonic testing attention of sound waves, it is a reflection of sound in directions other than its original direction of propagation. So what do we call this? We call it that scattering. Okay, scattering. The answer. Right. Now ultrasonic testing using the dash increases the efficiency of the processes by reducing the losses in the ultrasonic wave energy and due to separation between the surfaces. So, what is this? Using the couplant, okay, it increases the efficiency of the processes by reducing the losses in the ultrasonic wave energy due to separation between the surfaces. So, this is how we have done our MCQs, and the MCQs are also very important for you to understand. Now, these are the 10 MCQs that we have finished. Okay, then these are the references which you can refer and have a detailed learning about the topics that we have discussed today. There you will also be means that if you want to increase your knowledge in this subject, then these books will help you to increase your knowledge in this subject. Moreover, their elaborative text will also lead you to understand more content available in this subject on these topics. So, thank you all for listening me patiently, and thank you.